There's a good chance you're familiar with the concept of a vector. Whether it's from your math class, physics class, or some game engine run, vectors tend to be a portion of your experience. I'm sure that aside from those, you likely haven't had any first-hand experience with them, or found any other possible applications for them. I am here to tell you today that a ton of the devices you might use rely on them. However, it's not just that these devices use vectors exclusively. They rely on something called linear interpolation, or a lerp for short. Before I explain what lerping is and how it's used, I should briefly mention a couple of its applications, including color blending, font rendering, and animation. Lerping doesn't exclusively require a vector, although it can be better explained using one. A primary usage of the lerp function is the bezier curve. Using vectors which represent both a direction and a distance, we can draw a line via lerping. The lerp is best described as a mathematical equation representing the percentage traveled along the line from the start to the end. Lerping only one vector, however, is pretty boring. When we chain 2 or maybe 3 vectors together, something interesting happens. We generate curves. The reason this happens is because of chained lerp calls. By lerping every line on the first layer, we can create a second layer of lines using those lerped points. We can repeat that process on each layer until only one point remains, and we generate a curve by drawing a line based on that point. Despite bezier curves being among the easiest ways to visualize the lerp function, they aren't the exclusive use of lerping. Animations, font rendering, and color gradients, as previously mentioned, are other applications. Here are some visualizations of them.